Okay, college algebra. We're at the end of chapter R, so here's the chapter R review. It is just one page, like front and back, but there's a lot of problems on here. So I'm going to go through, hopefully with you, like one from each section, and then tomorrow, again, I'll post my, I don't know, the completed review so you can check your answers. But we'll do one together, and then you try to do one on your own when you're done watching this video. So here we go. Let's see if my computer is going, or my iPad is going to cooperate. All right, let's do the multiplied one together. So this guy, all we're doing is looking at our fractions and reducing. Okay, so this is 21 over 1. If it's a whole number, the bottom number is 1. And then I'm going to reduce anything that I can. So like 21 and 7 becomes 3 and 1. And then all I do is multiply my tops. So that is 9. The bottom number is 1, and I don't really need the bottom number, so I can just call it 9 and be done, okay? B is the same way, except it's divide, but don't forget to keep flip. So just an FYI on that, just be careful, okay? All right, add or subtract. This one you're adding, and so when we add and subtract, not like multiply, divide, we have to find a common denominator. So I'm going to do that. And I look at like my biggest number and I say, okay, does 6 go into 8, right? Nope, it doesn't. So let's try 1 up from 8, which would be 16. 6 goes into 16. Nope, it does not. So let's go another one up, which is 24, right? These are numbers that are divisible by 8, right? And so I just keep checking to see which one is divisible by 6, and 24 is divisible by 6. Okay, so I'm going to use 24 as my common denominator. Now, if I take 8 times 6, that's 48. So I could have used 48 as my common denominator, but that's not the lowest number that both of them go into. So I'll end up having to reduce at the end. No painting. So 24 is my common denominator. All right, what do you take times 8 to get 24? I take it times 3. So this 3 will have to be multiplied by 3. The 5, I multiply by what he needs. What do you take times 6 to get 24? You take 4, so 5 times 4. Whoop. And 3 times 3 is 9, and 5 times 4 is 20. So when I do that, I get 9 plus 20, which is 29 over 24. And that is what it would be as an improper fraction. If we reduce that and make that a mixed number, it would be 1 and 5 over 24. And I did not specify which one to do, so I don't care, I guess. Sure. All right, D is subtraction, but the only thing that you'll have to do different is 1 and 1/12. You'll have to change that into an improper fraction, so going back the other direction. See if you can figure out how to change that to an improper fraction, and then find your common denominator and subtract, okay? All right, I'll do the first row here, okay, and then see if you can figure out the other ones. Decimal to percent, you move the decimal to 2 places, so this is 12%. Fraction in lowest terms. This is 12 over 100, and I can remember that because 100 has 2 zeros and this has 2 decimal places. But I can then divide both of those by 4, I think. Yeah, and that will be 3 over 25. That is fraction in lowest form. Okay, so see if you can figure out how to do the other two on that problem. And let's move on. Okay, identify which subsets of real numbers these belong to. Okay, so we've got real numbers. Then we've got rational. We've got irrational. Irrational is like pi and the square root of any prime number. So square root of 2, square root of 5, etc., right? Rational numbers are any number that can be made into a fraction. So decimals that terminate or repeat, that's rational numbers. Within the rational numbers, we have the integers. Those are -2, -1, 0, 1, ... Then we have the whole numbers, which drop off the negatives, so 0, 1, 2. Then we have the counting numbers, or they call them natural numbers, and that is 1, 2, 3, etc., whatever. So each one of these we're getting further and further, like, narrowed down, okay? So, I don't know, let's pick, 2 of these, right? Let's go B and let's go D, right? B, square root of 7, that's going to be an irrational number. So it says identify which subsets of the real numbers. We already know all of these are real numbers, right? But this one is going to fall under the irrational numbers, okay? D is 4/5, so he can be made into a fraction. So he is first and foremost a rational number. Is he more than that? Well, I would have to look at integer next, and so that's positive, negative, whole numbers. 4/5 is not, so he is done. All right, I'm going to erase my comma. So those two are done. Okay, see if you can figure out A and C. All right, this one, we got unions and intersections, okay? Union means the marriage, that means everything together. Intersection just means where they overlap, okay? So I'm gonna do, let's do B and C together, all right? So if we're looking at intersection, A intersect B, I'm looking at this set right here and where this set intersect, where they overlap. You intersect at the top of a hill, and that's what we have here, right? Intersection, where do they overlap? Well, they don't have -6 in common. They don't have -2 in common. They do have 0 in common. They do have 1 in common, and they do not have 5 in common. So those are the only ones, 0 and 1. That is the intersection. That's where they overlap. Okay. All right. Now let's talk union on the next one. But they do this little, hold on just a second. Let me erase. They do this little like prime thing right here. Like, what does A prime mean? Well, this guy right here, this last set is the universal set. So like all of the numbers live in here and then some more probably than that, right? So A prime is all of the numbers that are in the universal set but that are not in A. So like -6 I can cross off because he's here. -2 I can cross off. 0 I can cross off. 1 I can cross off. 5 I can cross off. So A prime would be these numbers right here because it's everything that's in the universal set that's not already in A. Okay. And I want to know the union. Okay. So if I marry B and all of these numbers together, what can we include? Okay. Well, we know we can include -5. Okay, I'm going to go in order, so I know I can include -3. Like, we have double -5. Great. We have 1 -3, but that's going to get included, right? 0, I have 0 included. I have 1 included. I have 6 double included, so double bonus. And then I have 8. That is in the union, okay? Union, U, all that good stuff, okay? So see if you can figure out A and D, and there you go, okay? Let's do A together here. I have kind of a mess. I should erase some of this before, like, otherwise you're not going to read my answer key tomorrow. Ugh. Sorry. I'll erase all my circling and underlining and all the things. Okay, let's go A. Here we go. We got to figure out which one we do first or what parts we do first. So I look at like the innermost piece, right? And I see like a parenthesis here and an exponent. Okay, so let's deal with that thing first. 1 minus 6 is -5, and if I take -5 and square it, the negative is in parentheses. So this is going to give me 25 minus 18 in this little brackety thing, right? And then I've got my shell on the outside, and then I've got 3, and then I got plus all this stuff. You don't have to rewrite this every single time. If you want to do more steps than that, that's totally fine. Okay, now 25 minus 18 is 7, and 3 times 7 is 21, and -12 plus 21 is 9, and then this is 6 minus 9, which is -3, and that's my final answer. So that was kind of messy. All right, I'll try to make my work a little bit easier to read than that for like part B, I guess, or whatever. Okay. Next, let's see, number 7, we'll do 7 together. Power company charges one household this many per kilowatt hour, for power, and then this is their flat monthly rate no matter what. So write a formula for the charge C if it uses K kilowatt hours, okay? So no matter what, I'm getting charged the $24.89, and per kilowatt hour, I get charged 16 cents per K is what I've got, okay? Compute the monthly charge if the household uses this much, so I'm going to plug him in. C equals 0.16. You don't have to write all this work out. I just am, just so that you can go back and see it. I don't know what that becomes. 0.16 times plus 24. And I get like 216.89, I think. Let me make sure that that's right. Yeah. $216.89 is how much I'm going to get charged for that. Okay. All right. Okay. Let's do B, because B is going to be kind of gross just because of this exponent right here. Okay. So that negative exponent, I want to fix him first. And the only way I can fix that negative exponent is if I flip this whole thing around. Okay. So if I flip it, I'll zoom in here. I'm going to flip and make this 12y to the negative 2. Don't worry about the fact that those are negative. I'm not going to worry about that for right now. I'm just worried about the negative 3 on the outside. So if I flip that, it becomes a positive 3. Perfect. Fine. Let's distribute this 3 through. And don't forget that the 12 needs taken to the third power also. Actually, real quick. Let's deal with, I don't want to take 12 to the third power because that's going to be a huge number. Let's do this real quick. 12 and 4, I can reduce to 3 and 1. Let's do that. Then all I have to worry about is taking 3 to the third power, okay, because I've reduced him a little bit to begin with. So 3 to the third power is 27. 1 to the third power is 1. So that's what he is. Then I have y to the negative 6 power because I'm multiplying, right? X to the 9th power because I'm multiplying, and z to the negative 15 power because I'm multiplying, okay? Now I have a lot of people, I don't remember if it was Mackenzie or who it was, but like on the quiz or maybe on one of the homework assignments, I don't remember, you're trying to like flip this and deal with this negative at the same time you're trying to deal with this negative. Just do one at a time, okay? We just dealt with a negative on the outside, flipped them all. Now at the very end, I'm gonna fix these negative exponents, right? The x to the 9th power can stay, but these two need to kind of switch places. So 27 is just chilling on the top. This z now is going to come to the top and be z to the positive 15. And then the bottom, the 1 is there, but I'm not going to write the 1 because I don't need it. X to the 9th is just chilling, and then y to the 6th power is going to be down at the bottom also. So there he is, okay? All right. Those other two might be a little bit difficult, but I'll put those in my answer key tomorrow, okay? All right, rationalize, okay? I'm going to skip and I'm going to do part B here because you might be able to figure part A out on your own, okay? When you're doing this, you want to try to use the conjugate when you are getting rid of him. So 5 minus the square root of 3. Our whole purpose here is wanting not to have a square root in the bottom, okay? So if I multiply by the conjugate, the reason why I do that is because when we FOIL, those middle two pieces cancel out, okay? I'm going to write out all the work that you can skip if you want to. 5 times 5 is 25. 5 times negative square root of 3 is negative 5 square root of 3. Square root of 3 times 5 is positive 5 square root of 3. And the square root of 3 times negative square root of 3 is negative square root of 9, or just negative 3. Okay? On the top, if I distribute that through, that's 20 minus 4 square roots of 3. Okay? So these two are going to cancel. On the, let's see, on the top, I've got 20 minus 4 square roots of 3, and on the bottom, 25 minus 3 is 22. Now, there's one more thing that I can do, and if I look at all three of these numbers, I can divide all three of them by 2. So he will be 10 minus 2 square roots of 3 over 11, and that's what he will look like, okay? So that is part B, okay? A, see if you can figure out how to rationalize him, all right? Let's do 10B together, okay? Yeah, let's do 10B together. So here we go. This guy's going to be similar to A, except A is a square root and B is a cubic root. Okay, we can do this. We can do this. We've got 1, 2, 3, 4 pieces. All right, cubic root of 24. I separate these out. Cubic root of C to the 6th. Cubic root of D to the 10th. And then we have the cubic root of F5. Okay, here we go. There is nothing that I can take and multiply it by itself 3 times to get 24. But what I do know is I can take the cubic root really nicely of 8, and 8 times 3 is 24. So 8 times 3 gives me 24. The cubic root of 8 is 2, and the cubic root of 3 just stays underneath. Cubic root of 3, okay? Now, in order to be able to take cubic roots perfectly, exponents have to be divisible by 3. Right? And this one is, so that will just pop out as c squared because 6 divides 3 nicely. 10 does not divide by 3 nicely, so we've got to do something different with 10, okay? Now, I could put 6 of them here, right? But I could go bigger than that, and I could go 9 of them here and 1 of them there, right? So I'm going to do that one. I'm going to go the cubic root of d to the 9th, which is d3. And I'm going to go the cubic root of d1, which is just the cubic root of d1, or cubic root of d. This guy, I want to separate him, and I want to put 3 of them here, and I'm going to leave 2 of them there. If I'm going too fast, you can pause me, by the way. This is the cubic root of f3, which is f, and the cubic root of f2, which is just the cubic root of f2, okay? All right, now I put everything back together. So on the outside, I have 2, and c squared, and d cubed, and f, and underneath of my cubic root, I have 3, and d, and f squared. 3, and d, and f squared. And there we are, okay? All right, so this one over here again was a square root. We did a cubic root here. All right, now the rule here says that when you add, you can only add if they have the same base, right? So square root of 12 and square root of 3, I cannot add them together the way that they are right now. But if 12 breaks down into 4 and 3, and I take the square root of 4 and the square root of 3, that becomes 2 square roots of 3 plus the square root of 3. And this is like 1 square root of 3. 2 square root of 3 plus 1 square root of 3 is 3 square roots of 3. So that's what he will look like, okay? D, you're multiplying, so see if you can figure out how to multiply that together, all right? Let's do F together, and we'll see if you can figure out the other two, okay? This is a negative exponent again, all right? So the first thing I'm going to do is I'm going to flip this thing. Well, how do I flip it if it's just 8? This is like 8 over 1 right now, so I'm going to make it 1 over 8 to the 2/3 power. That's what I'm going to make it, okay? And 8 to the 2/3 power means the cubic root of 8 squared. And I can either square it underneath or I can square it afterward. I'm going to square it afterward because the cubic root of 8 is 2, and 2 squared is 4. So I've got 1/4 is what I've got there, okay? All right, this one is subtracting. So just don't forget to distribute your negative and then combine your like terms. This one, you cannot just take this 2 and distribute it through because there's a plus sign there. So we've got to FOIL him. So I'll get him ready to FOIL, and then I'll let you FOIL on your own. Okay, you got to FOIL him out, and then combine like terms if you can. But let's do this one together. Let's do D together. Now, these two are not conjugates, right? Like, this is not the conjugate of that. So we're going to end up with some terms in the middle that are not going to cancel out, and they're going to be kind of ugly, and that's totally fine. That will work, all right? So let's just see what we get. 5 square roots of x. Let's just do 5 times 2. 5 times 2 is 10. And then the square root of x times the square root of x is just x, right? Okay, then let's do this one. 5 square roots of x times 4 is 20 square roots of x, right? 5 and 4 go together. This guy, negative 3 times 3 times 2 square roots of x is negative 6 square roots of x. And then negative 3 times positive 4 is negative 12. And the only thing I can put together is these middle two pieces. So I've got 10x plus 14 square roots of x minus 12. And that's as far as I can go. Okay, see if you can figure out those other two by yourself. And let's do some GCF stuff. So I'm going to pick on B real quick. I'm going to pick on B. Okay, and B says I have 3 terms, and I want to do the greatest common factor. So what can I pull out? So 21, 14, and 35. 7 can come out. I have 2 A's, 3 A's, and 4 A's, so I can only take 2 A's out. And then B, I can take 1 B because this one only has 1 to give me. Okay, and then I don't throw them in the garbage. I pull them out front, and then I write what's left over. So if I divide, 21 divided by 7 is 3. My A's are all gone, but I have 4 B's here. Okay, minus 14 divided by 7 is 2. I've got an A and 3 B's. Then I've got 35 divided by 7 is 5. I've got 2 A's and no B's. So I need to move my little guy back over here, and there we go. That's greatest common factor. Okay. All right, factor by grouping. Factor by grouping. This is this thing, right? Okay. Do I do a factor by grouping down here? Yeah, I'm going to let you try factor by grouping on your own, okay? You try that one, because since there's only one of those. This one, factor the trinomials. These are both simple trinomials, so that makes it really nice. All we're doing is, I'll do G with you. I don't know why they went from G to B to, I don't know what my numbering system is here. I don't know. So we're trying to multiply to get negative 63, but when we add them, give us 2. Okay, so I've got P, 63 is 1 and 63, 2, 3 and 21, 4, 5, 6, 7, and 9. That's the one. That's what I want. So I want P plus 9 because I need to have a positive 2, and P minus 7. Now, we don't have this set equal to 0. If we did, I would say like P equals negative 9 and P equals 7, but I don't have that anymore. I don't have that yet, so I'm going to leave that off. They just say factors, so we're done. Okay? All right, factor the binomials. Factor the binomials. Well, let's just label these. Like, what is this thing? This thing is a difference of squares. Okay? Because he's minus, he's difference, right? And these two things are squared, like the square root of this guy and the square root of this guy, okay? You see if you can figure out how to break him down, all right? This guy is a sum of cubes. This guy, though, let's do C together because he is kind of a weird thing, okay? He is a difference of, I don't really know, right? I can't take the square root of 27, and I can't take this, well, I can take the square root of C to the 4th, right? But here's the deal. I can take a C out of both of these. So I have a GCF going on first. C times C cubed minus 27. Now, this is a difference of cubes because I can take the cubic right here and I can take the cubic right here. Okay? So, by the way, sum of cubes. So a sum of cubes. We'll write this down on a note card on Monday. Okay? I'll put all this stuff on a note card for you. Sum of cubes, difference of cubes. Here is the rule. Sum of cubes is A plus B. A squared minus AB plus B squared, okay? Difference of cubes, A minus B is the same thing, but your pluses and minuses switch around. So A squared plus AB plus B squared. That's what difference of cubes looks like, okay? All right, so we just have to figure out what our A and B parts are. So A is going to be the cubic root of C cubed, which is just C, and the cubic root of 27, which is 3, okay? So I'm going to leave this C out here. This C is just chilling. I've got this guy and then this big guy, okay? So I'm doing difference of cubes. This is a DOC. If I'm going too fast, pause it or something. So A minus B will be C minus 3. A squared will be this guy squared, so C squared plus AB is C times 3, or 3C, plus B squared is 3 squared, which is 9. And this is completely broken down. Okay, he has that extra C out in front, but he's completely broken down, okay? All right, simplify each expression here. We're just breaking stuff down. This one is x squared minus 9 is a difference of squares. This guy is a simple trinomial. Break those down and see if you can get an answer, but let's do B together. So this guy, what can we do to this top? We can take a 2 out, I believe. If I take a 2 out, I get Z minus Y. That's kind of odd, but whatever. All right, this guy is a factor by grouping. So here we go. If I group those two, because it's 4 pieces, so I have to factor by grouping. If I pull an X out, I'm left with Y minus Z. If I pull a 3 out, I'm left with Y minus Z. So my 2 pieces are X plus 3. Oh, shoot. And Y minus Z. Oh, dang. Not Z minus Y, those are different, right? Oh, crap. So nothing cancels. Except if I take a negative 1 out of this, I end up with negative Z plus Y, which is another way of saying Y minus Z, right? So if I pull a negative 1 out, I have Y minus Z, and those will cancel. Y minus Z cancels with Y minus Z. But then I have this going on here, and 2 and negative 1 makes negative 2 because you're multiplying. Okay. So that was a weird thing. If they're close to being like one another, but they're just different signs, just pull a negative 1 out. And that's what he will look like. Okay? All right. Multiply or divide. Let's do, I don't know which one is harder. Let's do a J because we haven't done one like that before. Don't forget to keep flip here. Keep flip. You're just going to have to figure out what all these guys are. Okay? So try that, and if you struggle, you'll have my answer key tomorrow to look at too. But this is multiply. We don't have to do anything here. And this one is a little bit hard because you have, none of that stuff is trapped. This is not trapped. Versus this guy is trapped because you have a minus sign. This guy is trapped because we have a minus sign, but this guy's not trapped. So like I can cancel any of this stuff with any of this stuff. But like I have to be careful canceling these two, right? The trapped things. So we gotta be careful of that. Okay. All right. The not trapped stuff we don't have to break down. The trapped stuff we do. Like this guy right here, I can pull a 2 out. And left over is a minus 5b. Oh, but look at that. A minus 5b and a minus 5b. That entire thing is gone. Okay. So let's do this. I'm going to cancel this 3 and this 12. Actually, you know what? I'm not going to do that. I'm just going to clean everything up because I have kind of a mess already. So let's just do this. If I take this thing and multiply by the only thing I have left over on the top is 2, this will be 6a to the 5th, b to the 7th. I'm like just putting it all under one roof, right? And then I have 12a to the 4th, b to the 10th on the bottom. And now I can just see it a little bit clearer. This 6 and this 12 will reduce to be 1 and 2. Okay, I have 5 a's on the top and 4 a's on the bottom. So I will have 1a on the top and then 7 b's on the top and 10 b's on the bottom. So I'll have 3 b's on the bottom. And that's what he will look like. Okay? All right. Adding, subtracting. I don't know. Oh, this is the last one. Yay. Let's do B. I don't know. We're subtracting. Plus, minus. Don't forget to do that. I do that every single time. All right. Then we got to break these bottoms down. So I've got x plus 5 and x plus 1. This is multiply to get 5, add to get 6. So 5 and 1. This guy, multiply to get 10, add to get 7. Is x plus 5 and x plus 2 to get 7. Okay, so I need my common denominator plus this guy. I've got 4. I've got negative 3. Those guys are just chilling. And my common denominator needs an x plus 5. He needs to have an x plus 1. He needs an x plus 5, but I already have one, right? And he needs an x plus 2. Okay, so I write those 3 pieces, and I'm just going to be lazy, blah, 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 blah. Those are all the same, right? Maybe I should write them out. Whatever. I don't care. All right. So what do I need to multiply by 4 to get this same bottom? He is missing the x plus 2. So I'm going to multiply him there. Okay. This guy, what is he missing? Well, I can't really tell. I got to look over here at this guy. He is missing the x plus 1. Okay. All right. And then what I'm going to do is I'm going to distribute my 4 through. So I've got 4x plus 8. And here I've got negative 3x minus 3. And then I just put it all under one roof. So 4x minus 3x is 1x, or just x. 8 minus 3 is 5. And oh, look at this. Oh, look at this. We got to have one more step, because guess what? X plus 5 and x plus 5, those can cancel. So all I have left is x plus 1 and x plus 2. So is that like my final answer, like that? But the problem is, like, those are all still on the bottom. So I've got to have 1 on the top. Don't forget that. Okay? Oh, that was fancy. So there's that. Okay? All right. I will leave my, try to do the rest of them. I will leave my answer key for you tomorrow.